Okay, Wildcats. Today we're looking at Journal page 21, Solve 2 and 3, Systems with Matrices. To solve systems of equations with the inverse, you first write the matrix equation AX equals B, where A is a coefficient matrix, X is a variable matrix, and B is a constant matrix. So let's take a look at the equation representing 1x, or to say the system of equations representing 1x plus 1y equals 8 and 2x plus 1y equals 1 is shown. So to write this as AX equals B, the 1, 2, 1, 1 become matrix A, the X and Y become matrix X, and 8, 1 become matrix B. To solve AX equals B, multiply both sides by the inverse A inverse. So you have AX equals B, you multiply A inverse by both sides, and the reason we do it both sides is because it's an equation. What you do to one side, you have to do to the other because of the equality. Now when you do that, A inverse times A is 1, X, which equals A inverse B. Okay, so if you would finish up your notes. Okay, now your notes are completed. Let's take a look at the examples. All right, now if you notice, we have a little rays of sunshine that's going to join us in the video. So I tried to ask it to go away, but unfortunately, it really wants to join us with this lesson. So we're just going to enjoy the rays company. Okay, solve the system equation using the inverse property of matrix A. Okay, so we need to write this as AX equals B. So 2, 4, 3, 3 times xy equals 12, 12. So now we have AX equals B. Okay, so AX equals B. So we multiply A inverse by both sides. Well, this becomes 1, so you're left with X equals A inverse B. So now XY equals A inverse, which is 2, 4, 3, 3 inverse times 12, 12. Okay, so now we're going to use a calculator. So to do that, okay, so we're going to go to New Document, No, Add Calculator. Now, to get the matrix here, we're going to press the button to the right of 9, this button right here. And we're going to select this box right here. And then that's 2, 4, 3, 3, click to the right, up key, -1, click to the right. Now we're going to press the matrix button again, so that button, 12, 12, enter. So X, Y equals 0, 4. So X equals 0, Y equals 4. Okay. All right, let's take a look at example 2. Our example 2. So again, we're going to rewrite this as AX equals B. So 2, -4, 3, -6, XY equals 12, -18. Okay. Now again, we know that AX equals B, and we need to multiply A inverse by both sides. So that's A inverse times AX equals A inverse B. Well, this becomes 1x, so X equals A inverse B. So now let's plug that in. So we have 2, let's just say, I'm sorry, XY equals 2, -4, 3, -6, inverse times 12 negative 18. So we're going to use our calculator. So we're going to go to New Document, No, Add Calculator. And let's see if I can brighten the screen up a little bit. It's about as bright as we're going to get, I guess. All right, so now we're going to press the button to the right of 9, right there. And then 2, 3, negative 4, negative 6. Click to the right. Up key. Now the up key is this button right here. Okay. Negative 1. Click to the right. Matrix key again. We need that box right there. So that matrix. 12, negative 18. Enter. Now you get singular matrix. Now if that occurs, you're going to have to go back and solve this algebraically with either substitution or elimination. Okay. So let's do that now. Okay. So it looks like, let's call this equation 1, and let's call this equation 2. Okay. Now it looks like we can do elimination. If we multiply the first equation by 2, the x's will cancel. So let's do that. So let's multiply the first equation by 2. So 2 times 2x is 4x, plus 3 times 2 is 6y, equals 12 times 2 is 24. And that's equation 1 times 2. Now we don't need to do anything to equation 2. Okay, that's an 18. Somehow my 8 didn't come out very nice looking, so let's fix that. Okay, now let's eliminate. So 4x minus 4x is 0, that cancels. 6y minus 6y is 0, that cancels. So we have 0 equals 24 minus 18 is 6. Well, whenever both variables are eliminated and you're left with a false statement, which 0 will never equal 6, we're left with no solution. Okay, let's take a look at example 3. So again, matrix. So it's 2, negative 1, 3, negative 1.5, x and y equals 12, negative 6. Now again, we know that ax equals b. We multiply both sides by a inverse. So a inverse times ax equals a inverse b. Well, that becomes 1. So x equals a inverse b. So now we have x and y equals 2, negative 1, 3, negative 1.5, inverse, so it's negative 1 times 12, negative 6. Okay? So now let's use our calculator. So I'm going to go to On, New Document, No, Add Calculator. I'm going to press this button right here, and I need this matrices. So 2, 3, negative 1, negative 1.5. Click to the right. Up key, this up key right here. Negative 1. Click to the right. Matrix button again. So 12, negative 6. Press enter. You get singular matrix again. So when you get that, you have to solve algebraically using either elimination or substitution. So let's take a look at the equations. It looks like, again, we can solve by elimination. If you multiply equation 2 by 2, the x's will cancel. So let's do that. So we're not going to do anything to equation 1. So 2x plus 3y equals 12. That's equation 1. This is equation 2. So if we multiply everything by 2, so that's negative 2x minus 1.5 times 2 is 3y equals negative 6 times 2 is negative 12. and that's equation 2 times 2. Well, the x's cancel, the y's cancel, so if 0 equals 12 minus 12 is 0. Now, when all the variables eliminate, and with the true statement, we say that that is infinite solutions. All right. We are not going to do example 4, so we're going to stop the video here. So if you would, finish up your examples and start working on your assignment, and have a wonderful Wildcat day.